Hi viewers, welcome back again. This is HVAC Simplified and today's topic for the day is understanding the basics of heating, ventilation and air conditioning system. So today we are going to see the simple basic understanding of what is required in an HVAC system. So the topic of today's are introduction to HVAC system types, HVAC piping system, HVAC air distribution equipment, fans and pumps, HVAC instrumentation and control, HVAC system commissioning. So let us start with today's topic. Now this article introduces the heating, ventilation and air conditioning system. The primary function for heating, ventilation and air conditioning system is to provide healthy and comfortable interior conditions for the occupants. Well, design system, efficient system, and to do this with minimal non-renewable energy and air and water pollutant emission. The purpose of HVAC design is both high indoor air quality and energy efficiency. These dual consideration requires an integral design approach. Rig's heating, ventilation and air conditioning system creates a climate that allows for maximum comfort. Though more costly to install and more complicated to operate, a chiller offers a number of benefits over a large number of individual package cooling units, including greater energy efficiency, better controllability, cheaper overall maintenance, and longer life. Now, by using a comprehensive approach to the design, designers around the world have succeeded at creating highly efficient air system that provides excellent comfort at significant savings. HVAC system reduce the environmental impact of Rig's building in several key ways. The most important for HVAC system is to provide Rig building occupant with healthy and comfortable interior condition. A carefully designed, efficient system can do this with minimal non-renewable energy and air and water pollutant emission to minimize the environmental impact. Cooling equipments that avoids chlorofluorocarbon and hydrochlorofluorocarbon eliminates a major cause of damage to the ozone layer. Now, as all we are aware of the CFCs and HFC, this terminology is related to the types of refrigerants which are used in an HVAC system. Basically, R22, the refrigerant which is the major cause of ozone depletion, is now completely phased out. So just to give you a brief flashback of the understanding for the refrigeration system, the commonly refrigeration system which are being used now are R134A, R410A and R407C. Even the best HVAC equipment and the system cannot compensate for a faulty Rig design. Problem for this type cause inherently high cooling and heating needs and consume unnecessary resource and should be corrected if possible. Conservation of non-renewable energy, though an intelligent architectural design offers a greatest opportunity for savings. The most important factor in these designs are careful control of solar gain while taking advantage of passive heating, daylight, natural ventilation and cooling. The critical factors in mechanical system energy consumption and capital cost are reducing the cooling heating loads they must handle. Now let us understand the HVAC system is not an individual standalone system. Major factors need to be considered while designing an HVAC system. The basic and the major important factors which are totally related with will create a huge impact on HVAC system are the building, orientation and the construction material. So the good the construction material is, the less the HVAC load. You need to understand these both goes in the parallel way. HVAC system types. Types of HVAC system design. There are several major HVAC conditioning system types in a widespread use today. These air system, hydronic and steam system, and unitary type system. Most system in use today falls into one of these categories or are a combination of variation of them. Each types of system has got their own advantages and disadvantages. Now if you look at this diagram, it's a typical air-cooled chiller where you have got air-cooled condenser, the expansion valve, the compressor and the evaporator, which is also equivalent to a compact package unit. So now depending on your system requirement and the project requirement, you need to choose any one of these systems or the combination of both or multiple design systems. Now let us see the advantage of water-cooled chillers. Higher efficiency, custom selection in large sizes, large internal capacities, indoor chiller location, and longer life. For sure, definitely the initial installation cost for a water-cooled system is higher than another HVAC system. But in the long run, and when you consider the lifetime cost analysis, this is the most efficient system as of now. Now just look at the basic HVAC purpose of an air handling system. The basic supply air, the room with the defined requirement, and the outlet air. In the following slides, we will study the components of air handling system in order to become familiar with the components, know their functions, and become aware of possible problems. Now you can see the main subsystem consists of an air handler, rooms, and other exhaust and supply system, including the terminal units, fresh air terminal, and the makeup air systems. The overview components, which includes the air handling units, the room where the air needs to be supplied, heater, terminal filter, control damper, louvers, exhaust grills, silencers, fans, filters, and etc. So the combination of all these systems and the components are essential to function in a proper and a conditioned way. The major components are weather louver, the silencer, the flow rate controller, and the control damper. Heating unit, cooling unit or the dehumidifier, humidifier, filters, and ducts. Air types. These are the filter classes which are defined and is required as per the requirement. So depending on the various system and the functions and the types of project, different types of filter classifications is required, and among which this needs to be considered depending upon the specification of the project. Primary filter, secondary filter, and HEPA filter. These are the few examples. Duct heater, room duct heater, and the silencer. Volume control damper, fire damper, and a dehumidification. Now this is just an example of a double skin air handling unit with the internal features in them. Now as you can see, the internal air handling unit consists of fans, filters, coils, HEPA filters if required, fresh air entry, and Return air entry. Fan coil units. Self-contained units. HVAC air distribution equipment. Diffusers, four-way diffuser, two-way diffuser, one-way diffuser, and the round diffusers. Cabin units. Return and exhaust grills. Fans and pumps components. The common types of fans are centrifugal fan and the axial fan. The centrifugal fan consists of radial, forward, backward, and roof ventilator type, and the axial fan consists of propeller, tube axle, and vane axle. These are the drawings where you can see the centrifugal fan and the axial fan and their components. Fan performance. Major issues causing energy efficiency losses to a centrifugal fan: circulatory flow between the blades, air leakage at the inlets, friction between the fluid particles and the blades, energy losses at the entrance, and partially failed passages. This is the operating characteristics of a backward curved centrifugal fan. Fan-duct system. Terminology. Primary air, conditioned air or makeup air. Secondary air includes space air, plenum air or the recirculation air. Transfer air, indoor air that moves from an adjacent area. System curve. Volume flow versus pressure losses and system operating points. Now the primary air is the conditioned air or the makeup air which is required in a conditioned space. The secondary air might include the space air, plenum air or the recirculation air. Fan modulation methods with the damper, inlet vanes, inlet cone, blade pitch and the fan speed. So the fan can be modulated by using all of these or any one of these parameters. Fan surge in a centrifugal fan occurs when air volume flow is not sufficient to sustain the static pressure difference between the discharge and suction. Fan stall in axial fan when smooth air flow suddenly breaks down and pressure difference across the blades decreases. The fan loses pressure capability drastically. Fan selection. Selection fan type plus determine the fan size. Important factors in consideration of selection of a fan are pressure volume flow operating characteristics, fan capacity modulation, fan efficiency, sound power level, airflow direction, and the initial cost. The table 15.2 is the comparison between various types of fans. Duct construction. The types of air ducts are supply air duct, return air duct, outdoor air duct, exhaust air duct. Duct selection is basically done based on the header or main duct, branch duct or the runout duct. Duct system. Maximum pressure difference between air inside the ducts and the ambient air. Commercial buildings Low pressure ducts less than or equal to 50 Pascal, maximum of 12 meter per second. Medium pressure system consists of 500 to 1500 Pascal. The maximum velocity consisting of 17.5 meter per second. Residential buildings will have 125 Pascal or 250 Pascal. Industrial duct, the delta P can be higher. The duct material example using UL underwritten laboratory standards class 0, 0 flame spread, 0 smoke develop, iron, galvanized steel, aluminum, concrete, masonry and clay type. The class 1 flame spread less than or equal to 25, smoke develop less than or equal to 50. Fiberglass, many flexible ducts. Class 2 flame spread less than or equal to 50, smoke develop less than or equal to 100. The duct's construction it also depends on the shapes of an air duct. The commonly used sections and the sizes are rectangular, round, flat oval and flexible. The major and the basic common standard practice for air ducts is known as magna. The sheet metal and air conditioning contractor National Association standards. Any air duct construction comes under this magna standards. Here you can see the few drawings of a rectangular duct, round duct, flat and oval duct, and a flexible duct. The commonly used types of ducts are rectangular and the round duct. Transfer joints and reinforcements. Duct specification, sheet gauge and thickness of duct material, transfer joints and longitudinal seam reinforcements, duct hanger and their spacing, tapes and adhesive closure, fire spread and smoke develop, site fabricated or factory prefabricated. This is the friction chart for a round duct. Duct fittings with elbows, converging or diverging T's and V's, entrance and exit, enlargement and contractions, means to reduce dynamic loss, turning angles, splitted pins, Assured duct fitting database, fitting loss coefficients. This is the fitting loss coefficient sheets from an ASHRAE standard where you will be finding depending on the construction size and the shape of the fittings. Air ducts design. Optimal air duct design, optimal duct system layout, space availability, satisfactory system balance, acceptable sound level, optimum energy lost and initial cost, install only necessary balancing devices such as dampers, fire codes, duct construction and insulation. Requires comprehensive analysis and care for different transport functions. Flow characteristics of a supply duct system. HVAC piping system. HVAC instrumentation and controls. HVAC system commissioning. The key elements of commissioning includes installation check, operation check, documentation, operation and maintenance manual and training, ongoing monitoring. So, installation check. Check installed equipment to ensure that all the associated components and accessories are in the place. Operational check. Verifies and documents that systems are performing as expected and that all sensors and the other system control devices are properly calibrated. Documentation confirms that all required documentation has been provided, such as a statement of design intent and operating protocol for all building systems. Operation and maintenance manual and training. Prepare comprehensive O&M manual and provides training for rig operation system. Ongoing monitoring. Conduct periodic monitoring after a school is occupied to ensure that the equipment and the system continues to perform according to the design intent. Corrective implemented commissioning is extremely cost effective and should improve the deliverability process, increase system reliability, improve energy performance, ensure good indoor environment quality, and improves operation and maintenance of the facility. Thank you very much guys. Thanks for watching these videos. Hope you like this video and I'll be posting my another videos very soon. Thank you very much once again. Subscribe my channel, like and comment.